Welcome to Ask and Learn.
Since we have an nth power here outside the parentheses, this suggests that we use the root test. So if we go ahead and call this term an, the root test requires that we look at the limit n goes to infinity, nth root, absolute value of an. So let's go ahead and rewrite this. So I'll use the fact from algebra that you've seen before, that if you take an nth root, that's the same thing as raising x to the 1 over n power. So I'll keep the absolute value here. This is all to the n power, and then our radical becomes 1 over n. So if you notice here, we're raising an exponent to another exponent. So we'll have to use another fact here from algebra. If you raise an exponent to another exponent, you just multiply the two exponents. So here, when we multiply the n and the 1 over n, they just cancel out to 1. And that leaves us with the limit as n approaches infinity, 1 minus n over 2 plus 3n in absolute value. Now, to make this easier to deal with, we can see here that n is bigger than or equal to 1 just by looking at the summation. So in this case, 1 minus n absolute value is just equal to n minus 1. Because n minus 1 is always bigger than or equal to 0. So we can rewrite this limit as n minus 1 over 3n plus 2. And if it helps you, you can replace the n with the x at this point and use L'Hopital's rule to take the limit. In either case, you see that this limit will be 1 over 3. This is less than 1, so we conclude that the series converges. And that's by the root test, and that's our final answer.